Okay. Hi, everybody. So my name is Omri, if you don't know it already, and sorry for not being there in person, but a family member of mine got a positive test to COVID, so I must stay home for about a week. But for now, I made this a workshop for you about decompilation and Ghidra and some memes that I laced all over it. So let's share my screen. So first of all, what is decompilation? So can I get maybe like some audience participation and see what you know about the assembly and the machine code? Anybody in the audience can participate. If not, it's okay. So assembly is pretty much like a text representation of machine code, which is the, let's say, 1s and 0s that the CPU would interpret and then execute. And when you write code in, let's say, C or C++ or Java or Golang or Rust, there is some compiler in the middle that would convert your code that is human readable and nice to read and to debug from that to 1s and 0s that the CPU can actually understand. But from our point of view of actually attacking systems and understanding possible bugs, we want to go backwards. So we want to convert from machine codes to a more human readable code. And that job is much more easier with a decompiler, which is Ghidra, in a sense. So today we'll become a TeraChad and learn how to use the decompiler to understand high-level logic, let's say conditions, loops, and some flags, possibly, by using the decompiler to pretty much elevate our understanding of the machine code. So what are our tools? So today we will probably need some Linux environments, or probably Kali if you already have that, and a terminal, because we want to interact with the binaries, and usually that is done via terminal. So probably I would, can you in the room over there, can you maybe ask everybody if they already have Ghidra, or if they might need time to get Ghidra running?
So does everyone here have Ghidra installed or some kind of disassembler? Yeah, it seems like most people do.
Yeah, no worries. So, okay, so given that you can open Ghidra, the first screen that you will see is this welcome screen that you first need to make a project, which, I mean, you can probably just create one and like store everything in that project, but we can create any. But once you make that project, you need to drag and drop your binary. That is possibly an ELF binary or like any kind of binary that you can run into Ghidra, and then you need to open it. When you open it, you'll see this view, and notice on the side you have the symbol tree, which is like a summary of every function, symbol, and variable that is in the code. And if you don't see that right away, there is the menu called window in the top that you can access that symbol tree and the compiler from there. And the compiler will pretty much show the C-like version of the code that of the portion of the program that you select. And this I mean, I think C-like because it's not really C that is written by a human. It's more like C that the computer makes for you. So it may look a bit weird, but it's better than debugging assembly. And one more window is the defined string window. So this is a table of every variable that is known at compile time that you will need to know. So if you know that you have a variable, for example, string or some number, like a flag, for example, you can get that variable from the table and you could copy and paste it to somewhere else. And that is pretty much all that you need for today. And if you don't already know, I have this short slide about running a binary. So in the challenges today, you will need to get the binary on your file system and navigate to it with the cd command. Optionally, you could use the file command to verify that it is a valid binary for your CPU. And to run a binary from your local path, you can just append // to it and maybe add any arguments in the command line. Otherwise, you can just press enter and it will run the binary with the arguments. So yeah, I think I've given you over the preliminary info for the first three challenges. So maybe I'll give you some time to work on it. And if you have any questions, I could demo the solution for you or give you some clues on my system. So like, how about 10 minutes for the first two challenges, I suppose? So yeah, so I'll be back. I mean, I'll stay here if you have any questions so far, but like this is how my Ghidra window looks like, and I can just, let's say, open the first challenge. And when you first open it, it will, so it will first ask you if you want to analyze the binary. So this is how it would recompile it. So normally I would also select the ones that are not in red. So I mean, select this one. Yeah. And this warning happens every time, and I just ignore it on my end. But yeah, so normally in most binaries, you have the main function where the program begins to execute. And here's the decompiled code that we got. And just a note that this string isn't the full string. So if you want the full string, you need to do some more extra steps like we showed in the slides. But yeah, so I'll be on. Oh, we have some in the chat. Oh yeah, just some jokes, no worries. Yeah, so if you have any questions, I'm ready to answer.
I've released the challenges on the ctf.monsec.io platforms. If you go there for the week whatever we're in challenges, there should be them under the reverse engineering category. Each challenge, it supplies the binary, and unlike the binary challenges that we did in previous weeks, the source code isn't provided, which is why this is known as reverse engineering. You have to get a previously compiled program.
So I think it's about time I can at least demo the first challenge. So if anybody struggles with the first question, they're welcome to ask me anything about it. I can actually I even show the code as well. No, this one. Yeah. So this is the second one. Yeah. So in the first one, I'll give you like a clue that we print. So we print something that we probably want, something that we don't want, and they both depend on this value of the string compare function from the standard C library. And oh, damn it. Okay. So does anybody know what the string compare function does in the audience? They're free to, I mean, you can, if not, I will just tell you.
Yeah, so does anyone know what the string compare function or the str CMP function does? Yeah, it compares characters in a string.
Yeah. So it returns 0 if the strings are identical. And they're identical because if we put this string as the input, and we know that this will be the input because we use the scanf function that would scan for user input. So if we run this binary, which I hope it will work because I compiled that also on my host machine. So let's say oh fuck. So okay, you know what? I will share it on my host machine because this is the VM, and yeah, so here's my, it's just, yeah, so that's the question, what am I? And because we know the code already, if we answer a meme, it will give us the flag, which is yeah, just like the flag. Okay. Yeah, so, and here's the flag. Also, if you are a smart boy, you can probably understand that if you just do that, and let's say the strings, you can also find that same string because it's not really encoded as anything. So you could probably use a shortcut, but the highlight of this challenge is to understand the logic of the program. So the next challenge is that we similar code, but this time I don't really mention the flag anywhere in the code. So it is still a variable, but you will need some other method besides these shortcuts to find the flag. So if anybody has any ideas on how to do it, they're welcome to shout it out in the into the microphone or in the chat. So as you can see in this, so I don't mention the flag anywhere, but it is available because it is still being exported. So I'll give you maybe like Leo, like how much time do you think is enough for this? Yeah, so I think I can maybe demo the second solution. So assuming everybody is ready, let's just share screen. So if you want to get any string, like any variable, this won't really give it to us unless it's like it's mentioned like a verbatim, like that, like a raw string in the code. And our flag is mentioned as a global variable, so it's not really available to us through this menu. But we can still go to the defined strings menu. And if we scroll down enough, first we need to add label. So now we know the name of the variable, so it's flag. We can copy it value. So let's say copy, and we can paste that to a text editor. And here it is. And it's also a meme, so why not? So yeah, this is just like a short summary of how you can get a specific variable. So yeah, and also I'll also give like a short intro to the next challenge, which is very similar to the previous one, but you need to do a few more steps to get the final flag. So let's yes, analyze everything. Yeah. So where's the where I saw it? So in here we're supposed to see the flag. It's right here. So okay, so where it was here. So I'm gonna go. Okay, that's a bit awkward. Okay, you know what? I'll be right back. I'll just debug it on my host machine. Yeah, just a second.
Testing. Yep. Omri, that could be the reason, but it's very strange because
Yeah,
you're defining it as a char array, aren't you?
Yeah, pretty sure. Yeah.
Yeah. So I don't know why it wouldn't show up here.
Because like in the every other challenge, it was like a flag variable in its label and some normal looking string, but now it's like a basic 4, and it's just could be a cool. Actually, could be a cool exploit, like that you could encode everything in like basic 4, and then you can hide from Ghidra.
Mm-hmm. Yeah, look, your guess is as good as mine.
So, I mean, normally this wasn't really my intended solution, but if you can just run strings and on this binary, you will see this basically 4 string. And for now on, the 2 steps that you need to perform are just like some cryptographic manipulation. So we see this is a basic 4, so we just undo it. So let's say no, oh wait. That didn't go attend. That doesn't seem to work. Oh, yeah, okay, yeah. Okay, this is hex, yeah. So this is the first step. We convert from basic to 4, and just to be cheeky, I put on some hex. So we can say from hex, and okay, and now we get the flag. So if you do these 2 steps afterwards, so like, I mean, I think it's just like a cool example of like something that seems normal, like a basic 4 string, but like a decompiler like Ghidra might ignore it, or like, so if you want to be stealthy and Ghidra and the NSA didn't really patch that bug yet, might be a good option.
From my experience from the recent Pico CTF, Ghidra can be quite wacky with globally defined char arrays. They might not understand like its size or anything like that. So yeah. Because
they have like an inter menu for that. Like they have like one menu for that thing only. So it's like a bit weird.
Mm-hmm.
Okay, and so I think I can just intro the next challenge, which is, so this binary called concatenate. It's not really written in C anymore. It's a different language that, yeah, let's analyze everything. So it might look more bloated. That's because it does a bit more, and it's not really, this is like a general purpose binary. So it's really, if you can find an exploit in that binary, please tell me, because I would care a lot, because it's my program. It's on GitHub. So, but so your goal would be to find the function session.stop and to find the variable name that is being returned in the end of the function, in the last line. And it would look a bit different than the C binaries, because there are a lot more. I mean, even now it takes like a bit more time to fully analyze. And if you have a guess as to what language this is, the source code is, and you don't know, I mean, it might be written here as well in the defined strings, but if you know your OSINT, or you know how to stalk someone online, you can find this source code on my GitHub. So yeah, if you have any questions, I am available. So yeah.
Which challenge is this for?
About the Golang challenge, like the cocaine challenge. stupid name, I know.
I mean, yeah, you can do a quick. Yeah, I reckon you can do a demo of it, maybe.
Yeah, no worries. So first, let's just. Oh, I need to open Ghidra again. No problem. So this binary was compiled with a Golang. So it's a neural language in C, so it has like some different package structures, like so like this. The difference is that when you let's just analyze, yeah. So when you click on the functions, you will see these letters. I think this is just a Ghidra being retro and like displaying each like possible module name in its own subsection. So you want to pay attention to the G section because in Golang the packages or the package name is defined by a domain, like let's say github.com. So like, okay, so analyzing a bit. But in G, you'll see this github.com section, and inside which you will see my package. And so this is how it works in Golang. So like, there's no npm or like pip in Golang. You just store it on your GitHub, and given that it's public, you can just publish anything behind that domain ID. And if you, I mean, in here you can see every public function that I expose in this binary. And in this top function, under session, okay, still analyzing. Yeah, so you can see this decompiled Golang code. And in the end, this is the solution, which is not, this is not really the actual verbal name, it's just the verbal name that Ghidra chose to display. But if you put this in as the answer, you'll get the points. So thank you very much. And I hope you are having a good pizza and good night.